Hello again. I'm Dr. Troost, and the last time in segment 12 we were talking about the bottom of a list of genes that vary, often very significantly and sometimes even very absolutely between and among racial groups around the globe. That's simply because evolution operates that way. That is, that any species that becomes separated into subpopulations and are separated by very large physical barriers, such as deserts or oceans or mountains, these subpopulations eventually, as they evolve and become adapted to their environments, will vary in many ways. And in the case of humans, that have even though their total number of genes, which is roughly about 30,000, is not very unusual, they are, of course, we egotistically think of ourselves as far more complex and very special animals, and we are justified in thinking that. But the truth is that it's really the complexity of human nature based on the supreme complex organ, the human brain, which is only about 3 pounds, but which contains very complex circuitry, acts like a computer in many respects, and has a number of complex components that can be influenced by genetic differences. One single mutation of a key gene dealing with the brain circuitry or neurotransmitters can alter the whole personality. So human beings are very complex, but the brain makes an enormous difference. And because it is, after all, the physical basis for all human behavior, and therefore modifications, the genetic modifications, can have a very big difference. Dogs, we know that over a few hundred years, we have bred huge personality differences, behavioral differences, differences in aggression, differences in intelligence, and degree of friendliness that are overwhelming. These differences are not due to thousands of genetic differences, but due to, in most cases, a few, no more than 3, 4, or 5 gene mutations can make all the difference in the world in what we see before us in our pets. A pit bull is hundreds of times more aggressive than a border collie, for instance. They are extremely dangerous animals, despite what their owners will claim. And the difference between a pit bull and a border collie might only be a few genes, really. But those genes are in critical places in the brain, which manifest themselves as a huge increase in aggressive behavior. So, looking at humans, we'll go over to this chart. And we're on number 13, segment number 13, of course. And I'm continuing with that list of genes for aggression. We have 3 or 4 candidates in humans, and I'm sure there will be more in the near future. But certainly one of them is very interesting, and that's called MAOA. In a New Zealand study with 442 people, they followed longitudinally children from childhood to all the way to age 26, and they really segregated them in terms of the study to those that were severely mistreated in childhood, those that were moderately mistreated in childhood, and those that were not mistreated in any conspicuous way at all, and they were the controls. And they found that the what we call a low MAOA group had much conduct disorder. They misbehaved frequently and committed quite a bit of crime over their roughly 26-year span. We are talking about a gene, MAOA, monoamine oxidase A, which has two forms. In the gene itself, there are several polymorphisms that allow the geneticist to dichotomize them into what we call low MAOA or MAOA-L and high MAOA, which would be MAOA-H. The difference being that the low MAOA is relatively inactive and or weak and does not metabolize neurotransmitters in certain circuits in the brain adequately. The high is able to metabolize them in an effective way, so that's why we call them high and low. The difference being that children that are high in MAOA, had no surplus bad behavior. Their behavior was fairly normal. They did not commit any unusual amounts of crime. Now, here's an interesting thing. The treatment of the children in childhood, the high MAOA group had no surplus misconduct, even with maltreatment. And that's very interesting. So they were resistant to the effects of maltreatment that the other group was not. Now, looking at the low MAOA group, we have two kinds. The high mistreatment by the parents and the moderate. They constituted together 12% of the total sample, and they did 44% of all the crimes. So this group, regardless of the amount of mistreatment, had very adverse effects. In other words, they were criminally oriented. And we come to the issue of nature versus nurture, and in this case you can see how genes and environment interact. We don't know exactly, but we know in a sort of a global sense that mistreatment of the low MAOA group results in a lot of bad behavior, a lot of misconduct, what we call conduct disorder, a lot of illegal behavior, robbery, rape, attacks, fighting, and so on. So that the theory is that the relative inactivity of this gene allows certain neurotransmitters, certainly serotonin, and perhaps others, to rise to elevated levels, and these elevated levels have a big effect on the behavior of the individual. So they are, in a sense, genetically handicapped, and the high MAOA group was not. They have actual resistance to, you can spank them and mistreat them, and they still do not commit unusual amounts of misconduct. So we have an interesting intersection here between the effects of the environment and the genetic constitution of the individual. It tells you that genes do not have to, if genes meet the right environment, and they are, in this case, abuse of the children take place, especially unusual abuse, excessive abuse, this will activate the genetic element, and the results will be the bad behavior that we were talking about. If there is no abuse in these children, there is much less likelihood that these genes will be triggered and will result in the phenomenon of bad behavior, the phenotypic bad behavior. So the environment makes a big difference, but the genes count too. Thank you very much.